Okay, Algebra 2 students, for Mr. Fry, we are not worried about 1, 2, and 3 quite yet. Later in the week we'll get that, but I want to go through 5 through 12 real quick. Remember in your notes, we're working with problems that look like that quadratic function, where we have these other letters H and K involved here. And remember, the vertex is going to be the H. Now remember, this is negative H, so it's going to be the opposite sign that you see in here. So see, it's being that it's negative H, so if you had like minus 2 here, this would be a 2, a positive 2 for the H. If this was a plus 2, then this would be a negative 2 here. Because this is a negative here, this is going to change the sign always of your H. And then K, you're going to just put whether it's positive or negative in there. So if this was 2, it would just remain 2. If this was minus 2, then it would be minus 2 down here. So that's the tricky part of the vertex. You may want to rewind that and go over that one more time. Now, figuring out the axis of symmetry, that's when x equals h. So when this value equals this value. And how do you find that? Well, you just do x minus h would equal 0. So when they equal each other, like say this was 2 and this was 2, using 2 again, 2 minus 2 is 0. So you know you'd want them to equal each other. So you just take them and you just do the x minus h, set it to 0, and then solve for x. And that would be your axis of symmetry. Okay, I think it makes more sense as I do some of these problems. And number 5 we did in class, and you could, take a look at that, and I'll explain once we get to number 7, because this one was done in class. Okay, now let's talk about number 7. Okay, here we go. So the vertex. The vertex here is 3 because this is minus h, and my h here is a 3. So that just stays positive. And then I don't have a k back here. So no k means that there's 0 back there. Okay, so that's my vertex, 3, 0. And then my axis of symmetry would be x minus 3 equals 0. So we just take this and just set it to 0 to figure out what they would, when x would equal h. Well, that would have to be a 3. Does that make sense? This would be 3 minus 3. That would be 0. So the axis of symmetry is 3. That means on a graph, you would be able to, fold it on where x equals 3. That would be like, so this graph that's right here, you'd be able to fold it there and you have like a mirror image on either side. That's the axis of symmetry. That's what that means. Okay, number 8 looks more like the example in the notes, because here I have, so this would be minus h. My h is 2, so here's a 2. And my k is a positive 4, so it's just 4. So my vertex is 2, 4. My axis of symmetry would be this x minus 2 set to 0, solve for x, and so my axis of symmetry would be 2. Number 9, my h is a positive 1, so that means that my h has to be negative 1, because remember this is minus h here. So 2 negatives would make a positive in this, so this is going to be a negative 1. And then my k is minus 3, so it's negative 3. My axis of symmetry is going to be x plus 1 equals 0, and I just solve for x, and that would be negative 1. Number 10, here is my h value, and once again, 2 negatives. It has to be a negative to make a positive, plus 4. So it's going to be a negative 4 for my h value. My k, there's nothing back here, so that's 0. And then I just set this to 0, x plus 4 equals 0, and that gives you negative 4 for 10, for the axis of symmetry. Number 11, I have minus 5, so my h is just 5, and my k is a positive 1, so I have a 1 there. That's my vertex, 5, 1. And then for my axis of symmetry, I just take this and set it to 0. X minus 5 equals 0, and I solve for x, so I add 5 to both sides, so x equals 5. Number 12, my h is going to be a negative 6, because this is supposed to be minus h here, and so 2 negatives would make this positive. so negative 6, and then I have a positive 10, so my vertex is negative 6, 10. My axis of symmetry would be x plus 6 set to 0, so x would equal negative 6. Okay. All right, moving on to this one right here. My vertex, once again, same thing I've been doing. This is going to be a negative 2 because negative plus, remember, it's usually a negative here in that quadratic function. So 2 negatives make this positive, so this has got to be negative 2, and my k value is 4. I do the axis of symmetry. X plus 2 equals 0, and subtract 2 from both sides, so x equals negative 2. This is going to open down. How do I know it's going to open down? How do I know it's going to open like this? It's because there's a negative out here in front of everything. When it's negative, think of a frowny face. Negative, sad, frown. It's going to open down. So that means this vertex is the maximum point. It's the highest point. So it's going to be a maximum. And so the maximum minimum value, the maximum value is that vertex, negative 2, 4. It's the same. My y-intercept, I just set my y when x equals 0. And I just work out the problem, and I get negative 4. So my y-intercept is going to be negative 4. In other words, it's going to cross the y-axis right here at negative 4. Okay? So I just had a few points there. He went over in the calculator how to go through and how you can do it in the calculator to get more points to make it look a little bit better. I'm not going to go through that here right now, but maybe in the future I will. So here is number 17. It's positive, so it's going to open up. So that means opening up, the vertex is going to be a minimum value. Figuring out the y-intercept. This is how you figure out the y-intercept when x is set to 0. So that means it's going to cross the y-axis at 11. And then we did this in class. Domain is going to be all real numbers because it keeps going in this direction, so the x values are going to be, it will cover all of them. And the range has got to be greater than or equal to 2. So everything above 2 is going to work. Okay, here's how you do number 18. It's going to open down because it's negative. So this is going to be a maximum. That 5, negative 2. So 5, negative 2 right here. That y-intercept was negative 7. So if I can go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, it's going to be more shaped like this. Once again, the calculator method that he explained in class would get you some more points in there, but that's basically it. Okay. So this one, the domain, once again, if we're going to do domain, it's going to be all real numbers. Because it's going to keep going in this direction forever, in this direction forever, so it's going to cover all real numbers in x. But as far as the y, it can't be anything above negative 2. So the range is going to be y is less than or equal to negative 2. So it's everything below negative 2. So just take my pen and everything down here would work. Any number would be covered in that at some point. Okay, 19 looks like this. Got the vertex, got the axis of symmetry. You know how to do that. It's positive, so it's going to open up. Smiley face, think of positive. If it's if no negative there, so it's up. So it's going to look like a smile. Okay, and so that's going to be the minimum point. So the minimum point is going to be 2, 0. So it's going to be 2, 0. Y-intercept is 4. So 1, 2, 1, 2. So it's going to look like that. It's going to look like that. So once again, the domain, all real numbers. And the range would be y has got to be greater than or equal to 0. So it's going to be everything above 0 would work for the range for y. Okay, hopefully this helps, and we'll get into more problems, I'm sure, later in the week. On this, yeah, we definitely will, 13 through 15 and 1 through 4 later this week.